So the word orthogonal is not a word that we used very much in our other curriculum. All it means is perpendicular. And what do we know if things are perpendicular? They're at 90 degrees. And if they're at 90 degrees, then cos of 90 degrees would equal 0. And if cos of 90 degrees equals 0, then you know that the dot product of u dot v has to equal 0. So if we do the dot product of these, it's going to be 2m times 1, which is 2m, plus m times 3m, which will be 3m squared, plus 8 times a minus 1, negative 8, equals 0. And so we have 3m squared plus 2m minus 8 equals 0. Does it factor nicely, or are we going to have to go to the quadratic formula? Well, let's try it. If it factored nicely, it'd have to be 3m and m. Anything work to give you 2? So I'll go 4 here and 2 here to give 6 on the outside and 4 in the middle. Yes, we'll make the 6 positive, 4 negative. Sure enough, it works. So m could be negative 2 or m could be 4/3. The math wasn't that hard. If you think about what we just solved, that's really quite amazing. You had 2 vectors in 3 dimensions going in directions which you did not know which directions they were going completely, because you had a value of m here that you didn't know. But they were related somewhat. And you were able to say that quickly that, oh, if m is minus 2, then they're going to be at 90 degrees to each other. That's a pretty amazing result. I don't know if it's going to help you with your grocery shopping next week, but that's pretty fascinating. If I write u as 4 minus 3, that means it's going 4 over in the x direction and down 3 in the y direction. To write a vector that's parallel, all you have to do is be going in the same direction, but it could be longer or shorter, but it just needs to be parallel. So any value that you put in front of here will give you something that's parallel. So let's say k is 2. 8 minus 6 is parallel to 4 minus 3. If you pick k as 3, you could have 12 minus 9. That would be parallel. Even if you put a negative number in there, it would still be parallel, be going in the opposite direction, but the 2 vectors would still be parallel. To make sure something's not parallel to you, you just have to make sure it's not a multiple of 4, negative 3. You could change one of them. 8, negative 3 for sure won't be a multiple of 4, negative 3. There's no value I can put in front of 4, negative 3 like I did with this k, so that I get 8, negative 3. Now for writing one orthogonal to u, what's going to need to happen is you could think the dot product has to be equal to 0. And probably what's the easiest in 2 dimensions for this is to think back to your lines and slopes from before. If two things are perpendicular or orthogonal, their slopes were negative reciprocals, which just means that you flip the fraction. And if one fraction was positive, you made the other one negative. If one was negative, you made the other one positive. So here we can think of this vector 4, negative 3 like a fraction, like a slope. And if I flip it to 3, 4, then this vector here, sure enough, when you multiply it through, you're going to get 12 minus 12, which is 0. And that will be orthogonal. What do you think? Do you think we can get through this one more? You think the bell's going to ring? We can try. We'll see how we do. Two vectors, v and w. You want to find if they're parallel. So if they're parallel, here's my vector w, which is 1, negative 3. And here's my vector v, which is 2x. Perfect. What would I have to multiply w by to get that 1 to be a 2? Right? If I multiplied it by a 2, I would say that the vector 2, negative 6 is parallel. So then what would x be? Negative 6. If they're perpendicular, then the dot product will equal 0. And I'd have 1, negative 3, and 2 and x here with the dot product. Ooh. Which will be 2 minus 3x. Need to make that equal to 0. And x would be 2/3.